Hi, my name is Gabriela and we're going to study together advanced functions, which is the course studied in Ontario in grade 12, is the prerequisite for calculus and vectors, and it's known by its code MHF4U. I usually start by asking my students what a function is, and surprisingly, though we're speaking about advanced functions, nobody knows what a function is. So that's why I start usually with the definition of a function. A function is a relationship between the elements of two sets, such that for each element in the first set, there is one and only one corresponding element in the second set. Well, now if I asked anybody to reproduce it, nobody will know. So let's see what it really means. If I have the two sets, let's call them A and B. As you might already know, they have names. The first set is called the domain, and the second set is called the range. And I'm gonna take some elements in each one of them. So let's take at random 1, 2, 3 in the first set, and let's consider A, B, C, D, F, G, I don't know. In the second set, I'll show this correspondence that we're talking about in the definition by using arrows. So again, the correspondence should be such that each element in the domain has one and only one corresponding element in the second set. Well, instead of using element and corresponding element and so on, I would tell you from the beginning that the elements in the domain are called arguments and are usually denoted by X, just a convention. The elements of the range are called images and they're usually denoted by Y, or I'm going to get back to the other notation a little bit later. So I'm going to show the correspondence between the elements of the first set, between the arguments and their corresponding images, using arrows. So I'll choose at random the corresponding element for 1 to be C. So far, my diagram doesn't show a function. Why not? Because not each argument in here has an image. 2 and 3 don't have corresponding arguments. So let's show them. So let's say for 2 the corresponding element is B, and for 3 the corresponding element is D. So now we have a function because each argument, 1, 2, 3, has a corresponding image, one and only one, not more than one. Okay, so the corresponding image for 1 is C, the corresponding image for 2 is B, the corresponding image for 3 is D. And if I name my function f, I give it a name, okay, then I can get back to you with the other notation. As I said, we can denote it by y or by using the name of the function. In my case, if is f, I can say f of x. It's just like f embraces the argument. Then why would we use y? Why would we use f of x, and when? So look at the way I'm writing y. It takes only 2 lines. Well, as I'm supposed to write f of x, I can tell you the story of my life while I'm writing it, okay? So the reason of using y or f of x is simple. We're using y just for simplicity reasons. Then why do we need f of x? Well, because if we have in a question 2 or more functions, we can't call them all y's because we can't differentiate them. It's just like naming all of your children in your family John. So once you call John, everybody's coming to you. So, well, people might ask, then why don't we use y1 or y prime? Well, simply because these notations are already taken for something else, so by something else. Now let's see a review. To have a function, we have a domain and the range, and for each element in each argument of the domain, we should have one and only one image, denoted usually by y or f of x. I'm going to show you an example here, and you should decide if this is a function or not. So consider 1, 2, well, in the first set, and 3, 4 in the second set. If I show the correspondence like this, would this be a function? Well, if you said no, yes, you're right, because 2 doesn't have an image. Is it right? That's what you thought? Okay. Okay, let's assign to 2 a value. Is this a function? If you said no, yes, you're right. It's not a function. Why not? Well, if you said because 4 has 2 lines coming in, that's not the reason. The reason is, and watch the definition, it says each argument should have one and only one image, not 2 images. So do 1 and 2 have images? Yes, they do. So each one of them has one image. But 1 has 2 images, not 1 and only 1. It has 2. Therefore, this is not a function. So how about now? If I represent this, is this a function? Well, if your answer was yes, yes, you're right. It is a function because every single argument has one image, and only one, not more than one image. So the image for 1 is 4, the image of 2 is 4. Well, people say, well, it's the same. So how come it is the function? Well, the function says that the arguments, each of the arguments should have one image. It doesn't say that the images should be the same or different, or it doesn't say anything about the images. So this is a function. In math, we don't really use all the time diagrams. We use in math tables of values, where we show the correspondence I've shown before in a chart using x and y. Okay, so the arguments in the first column and the images, the corresponding images in the second one. So if I have in the first column 1, 2, 3, and in the other, do you remember what the corresponding images were for 1 and 2 and 3? Let's say if we have that 1, 2, 3, A, B, C, D, 3 and C, 1 and A, 2 and A. Okay, so the corresponding image for 1 is A, the corresponding image for 2 is also A, the corresponding image for 3 is also A. So you can see, sorry, it's C, not A. So you could see here that each of the arguments has 1. What if we had a situation like that? Well, then you would say the corresponding image for 1 is A, the corresponding image for 2 is A and C, A and C. So because of that, this is not a function. Okay? I mean, the whole thing is not a function, not only. But this is the reason. Because one element has 2 images. You could see this in a trickier way than might trick you, given in this format. So the same picture, x, y, can have 1, 2, 2, 3. And for the corresponding image for A is 1, for 2 it was A and C, and for 3 was C as well. So now you might say, oh, each element has a corresponding image, one and only one. No, it's not true, because 2 here is written twice. We have only 1, 2 in the first set. There aren't 2 of the same value. So this might be tricky. Pay attention to that. So to recap, given a relationship, you need to be able to determine all the time its domain, its range, and if it represents a function or not, based on the definition I gave you before. Functions have 4 forms: algebraic, graphic, numerical, and verbal. Which one do you think is the easiest one? Before you answer my question, look at some of the examples, because you might be in trouble. For the algebraic form, I could give you a form like this one. What can you tell me about that? Nothing? Well, neither can I. The graphic one would be a chart like that. I'm going to get back to the other forms, numerical and verbal. Numeric would be a chart like the ones I've shown you before, but with thousands of numbers. And the verbal one might be a word problem. So which one do you think is the easiest one? If your answer was graphic, then you're right. Because pretty much everybody can understand the drawing and tell me something about it. It goes up, it goes down, and things like that. Regardless of the form that the function is given, you have to be able to juggle between these 4 forms. So if a function is given in the algebraic form, you are supposed to be able to draw the its graph, to create a table of values, to make up a question, a real sentence, a real situation, and so on. The 5 basic types of functions studied in this course are the polynomial functions, rational functions, exponential functions, logarithmic and trigonometric functions. The course will end with a combination, like a unit that's called combinations of functions, because we don't really have all the time pure polynomial functions or pure rational functions. All of the functions, 90% of the functions that you're going to encounter are a combination of all of them in real life. That's all for today.